It's been a pleasure to present here in the past. I'm going to try and take it in a slightly different direction. Often I'm talking about how we can get carbon down in the soil. Today I'm going to talk about why the carbon in the soil is so important for the changing climate that we've got. And amazingly, a lot of the talking points are actually very similar, but just having that slightly different framework. Out of curiosity, so I can know what parts to spend more time on and less time, how many people have heard me speak, my husband Paul speak, or the two of us speak together? Okay, great. I was sort of assuming that. So regenerative agriculture for a changing climate, really there are three spheres here. I am really on the front line. I'm running the farm. I'm really focused on getting the soil healthy, creating food for our local community. I'm also definitely working with our local markets, farmer to farmer, and so forth. All of these are super needed, and I'm thrilled that so many of you here are working on the lower side of this because I am working on the upper side of this. So just wanted to have that framework to start us off with. And then I've got to start with a picture of our farm, our soil, our carbon, our biology. So this is a picture of the main part of Singing Frogs Farm. Singing Frogs Farm is an 8.5-acre property about an hour north of the Golden Gate Bridge. Our productive land is about 2.5 acres. There's a lot of native space around that to support that as well, and then our home and other space as well. About 45% of our food goes out through our CSA, our community-supported agriculture. About 45% goes out through 3 local farmers markets, and the last 10% goes to a couple of restaurants. So about over 99% of our food stays within 15 miles of the farm, which really feels good, and that's one of the solutions. It's not what I'm going to talk about. I'm really going to talk about the soil today, but definitely an important part of that. We have been on the farm since 2007, and we definitely didn't start out with the most resilient farming, but I'll get to that in a minute. Let's just keep... I'm going to talk about working with a changing climate, and these are some of the things that we've had to deal with. Can you guys see the green arrow? Okay, I can't because I've got a blinding light. Great. So fires, both in 2017, 2018, this one hit us really hard because we got frosts and then really, really poor air quality so that the frost wouldn't lift all day. It was really harsh on our farm. Floods, about 1/5 of our agricultural space goes underwater every year, except for when we have a major drought. So that's definitely a challenge. I don't know if you guys can see this. All the lower fields there are underwater right here. And that's just seasonal, but our soil is what helps us make it through that. Frosts, we never know what it's going to be like, right? In the wintertime. Is it going to be a warm winter? Is it going to be cloudy? Are we going to lose a lot of our brassicas? Is it going to be sunny? Our brassicas are going to do great, but really cold. We're going to lose all of our light crops. So a lot of different parts in that. Okay, getting our hands dirty down in the soil. I've got to start with something super basic of what is soil. This is super simplified, but most soil is really air, water, and minerals. The part that we're all really concerned with is the biology, is the organic matter, the soil organic matter, part of which is actual living organisms, part of which is roots, and the rest is that humus, which is the decaying part of it, the ability that, what allows for life. One thing I love thinking about is our planet has biology. That's pretty amazing. The rest of this, the other 95%, really is chemistry. We know of thousands and thousands of planets here, Mars, for instance, that have chemistry. But that we know of one planet that has biology. So we need to work with that. So the last couple of years, people have actually enjoyed seeing a couple of slides of our farm when it wasn't quite so regenerative. So this is 2008. You can see some major tillage. We've even got the tractor out there. When we were doing this, we were not quite so intensive. We were definitely tillage-based. We had a lot of pests and weeds. Again, a lot of tillage. And now I do want to touch briefly on tillage because it is one of the major agricultural practices that is very detrimental to soil. And I like using a couple of quotes from some bigger organizations, Food and Agriculture Organization of the UN. Tillage is one of the major practices that reduces organic level in soil. I have to do this so you guys can understand what's really happening there. Soil is made up of aggregates, really clumps, right? Those aggregates hold not only the biology in the soil, but the nutrients in the soil. When you're doing tillage, you are breaking up those aggregates, making a nice fine powder that gets rid of your weeds, gets rid of your biology, all that messy stuff, so that farmers can put in just what they want, input, so they can get out just what they want. We know that that isn't quite as simple of a equation, but what's happening when those aggregates are broken up, you're increasing the surface area in the smaller aggregate compared to the volume, which means oxygen is in contact with more of the soil, which means you have more volatilization of the compounds in the soil. The soil organic matter is made up of 57% carbon, so that carbon joins with oxygen, becomes CO2, nitrogen joins with oxygen, becomes nitrous oxides, and so on and so forth. So it's a very direct release of compounds to the air, increasing greenhouse gas emissions. Those are just the compounds that as farmers, gardeners, we need in our soil. Carbon for soil structure, nitrogen for plant growth, at a very, very basic level. Also talking about the biology, I love this quote: tilling the soil is the equivalent of an earthquake, a hurricane, a tornado, and a forest fire occurring simultaneously to the world of soil organisms. Simply stated, it is bad for the soil. This is from our USDA. We know what's right. It's just that our practices and our policies don't necessarily match with that. And then we know, because we're all here at Soil Not Oil, that 2/3 of our soil carbon have already been lost. They believe that our pre-cultivated topsoils were 6 to 10% soil organic matter. Today, 0 to 3%. California, as of 2016, 1%. But what we have found on our farm is we need to booster that life. We find that the more life that we get going on the farm, the more life that we're able to support. And that's really the resilience that we have when we have uncertainties coming at us. So, Singing Frogs Farm now, very focused on soil, very focused on no-till regenerative practices. And that has brought us from our soil, from those pictures of tillage. This is what it looked like. Lots of weeds, lots of pests, not very intensive at all, to with a soil organic matter of 2.4%, to these days, depending on the field, it's anywhere from 8 to 11%. So I'm going to go through the principles of soil management. I think these are super important for everybody to understand, and not only for a vegetable farm like myself, but these apply to everyone. Paul and myself did a talk with Gabe Brown, who does regenerative ranching in North Dakota, as well as grains. Those can definitely have a big impact. And we had a great time, him talking about how he did these things one by one on 3,000 acres in North Dakota with cattle, and we talking how we did it on 3 acres of vegetable in Northern California. It was a hilarious talk. So the first one, disturb the soil as little as possible. We just talked about why we don't want to do that, why we don't want to till, why we don't want to break up those aggregates, those ecosystems. We want to keep as much life in the soil as possible. What you're looking at here, this was an escarole harvest, and we had just cut this head of escarole right at the soil level. All these roots will stay in the ground, and you're looking at that cut head with all the earthworms around it. And when you see earthworms, those you can see. What you aren't seeing is all the other biology. So the earthworms will indicate that you've got more than that. The second one, keep living plants in the ground as often as possible. This is really why. I got this from Christy Jones. The first thing, you want to photosynthesize. You want to take that carbon back off of that CO2, put it in the plant, create glucose, then resynthesize that glucose into a myriad of other carbon-based products. Then your plants are going to exudate that out their roots and create humus. They're going to bring that carbon straight back into the soil. So as a farmer, I want as much photosynthesis happening as possible. This is a fun little slide actually showing that happen. There we go. Maybe you guys have seen this. This isn't a petri dish, but this is a root actively pushing sugars, pushing carbon out its roots, feeding the biology, initially feeding the fungus and the bacteria right around those roots hairs that are then going to feed everything going up the soil food web. You can see here the plants Some of it is decomposing into organic matter, but you're also feeding the fungi, the bacteria, which are then feeding all the other organisms in the soil. This is what we want. We want high biology in our soil because it's going to hold the soil in place, it's going to hold the carbon in place, it's going to produce healthy food, it's going to produce a healthy and resilient farm that can go through a lot of different climate instabilities. This is a video. Paul, myself, and our kids went onto a neighbor's vineyard. This neighbor has the same soil that we started off with. And what we're doing here is we're doing a slate test. We wanted to look at the aggregation of the soil. And as you have high soil biology, you are going to have that soil hold together. So here he's digging for some soil at a 6 to 12 inch depth. You can see that was a little bit challenging there. This is about 100 feet away in some cauliflower patch. Again, taking off the topsoil, going down 6 to 12 inches, getting some of our soil. A lot of people worry that we don't actually have aggregate because our soil is so loose. You can see the difference between the two on either side. And now this test, you put it in water and see how it holds together, or how it doesn't hold together. Our soil is over here on the right, had actually been in the water already for a minute. You will see occasional bubbles of water coming up, but is it falling apart? No, it's being held together. What about our neighbor's soil over here? Absolutely. I'm guessing this is a 1 to 2% soil organic matter. This over here is from field 3 that has a pretty high soil organic matter. That's probably 10% soil organic matter over there. So all the biology is exuding those sugars. Some of them are supermolecules like glomulin and others that they're just now learning about. The purpose of those is to hold together those aggregates. They don't want it to fall apart and become this foggy mess, right? They want it to hold together so that they can have their interactions, they can live in that community. So this is what we want to see. The better aggregation that we have and the better holding together, the more healthy your soil is and resilient. And it actually keeps going on until it's just completely foggy, but I'm going to continue on. So again, samples taken about 100 yards apart, 6 to 10 in the depth. So this is from a tillage-based perennial crop. They do use winter cover crops. And then this is soil from ours, annual crops, 3 to 8 different crops per year, all done manually, and no tillage of any sort. So you can see the difference pretty clearly there. We also were able this year to do infiltration tests. I don't have visuals for this quite as well, but where you get a ring in the soil, you pound it in, and you put on water to see how quickly it infiltrates. We did it on our neighbor's property. We did it on another organic vegetable farm that I think of highly in our community, and we did it on our farm. And what we found is it took 25 minutes to infiltrate an inch of water on one of our nearby vineyards. It took, which is actually about moderate for most agriculture. On our neighbor's soil, it took 6 minutes, which was moderate to good. On ours, it took under a minute, which is about like a forest floor. It just went and soaked right in there. Why is that important? Because with climate change, we're having fewer rain events that are much bigger. So we want that water to be a sponge and just soak that water in quickly. That is one part of what soil organic matter does. It also then will hold that water in place. It will hold that water in place, and we see that manifest in not having to use as much water for irrigation. When we started out, and what I see on a lot of my neighbor farms is at least 50 minutes of irrigation every night or every other night this time of year, if not overhead during the day for several hours, honestly. What we're doing on our farm, we started off with that 50 minutes of irrigation every other night. These days, it's about 25 minutes every 5th night. And that's not because we're starving our plants. That is simply because we have the soil that is able to hold that water in place. So think what that does now if you have a drought. Think what that does when you have, a really quick rainfall. You have 15 inches of rain in a day or something like that. That's what we need. That's the healthy soil we need. The third principle of better soil management, up here in the right corner, is grow as many different species as possible. Bringing in a very different system, looking at prairies, and this is because there are numbers in this, they will have over 500 different species. 85% of the vegetative biomass is actually underground, and 60% of the total net primary production happens underneath ground. We want to try and mimic this as much as possible on our farm. That's why we don't grow 5 crops. We have over 100 different varieties on our farm, primarily of vegetables, also of flowers. You can see some flowers in the foreground here, and then also of fruits. I could probably point out 20 different varieties just in this photograph alone. If you look at the upper right up here, crop diversity. This is really climate resilience. This August, for instance, we had a really late tomato crop. They were gorgeous plants, and they were green and green and green and green. And I'm like, come on, guys, please ripen up, please ripen up. We probably lost half of our ability to sell our tomato crop because it came in about 6 weeks later than usual. Well, with 100 other crops out there, I've got the resilience to say, well, the tomato crop is late, but we've got X, Y, and Z, and that helps us make it through. Every year, we know that a certain number of our crops are going to be partial failures to complete failures. But some will be astounding successes as well, and that will help us through it. So crop diversity gives us climate resilience, also gives us economic resilience. Having as many different diversities as possible was this principle that I started off with. This is one of the ways that we will do it if we are focusing only on annual vegetables. So what you're seeing here, you're seeing cauliflower plants, which when you plant them out are about this big and are spaced pretty far apart. And we've got about a 60% cover of a lettuce in between. This is a panisse lettuce. Now, those panisse are going to harvest out, same crop here, about when the cauliflower are about this size, when they start to close canopy. So I'm getting 1.6 crops out of here, definitely economic resilience there. But what else are we getting? We're getting soil cover, we're keeping the moisture in the soil, we're photosynthesizing, we're blocking our weeds, so forth and so on. We're having more life, and it's helping create more resilience. Here's another example with leeks and lettuce that we might do. Here are tomatoes going in with escarole and frisee on the side, tomatoes going in with red butter lettuce on the side. So we'll do as much of this multi-cropping as possible. Brassicas, we grow a lot of brassicas, and they can be sort of hard on the soil. One of the things we started last year was planting them with fava beans. Fava beans are actually used as a cover crop very frequently, and part of the reason is they're nitrogen fixing. And so we planted it in amongst, didn't let it grow until it got to bean, but harvested it at the leaf size. Oh my gosh, in the spring, it is so tender. It tastes like peas. It's just delicious. Here's my daughter and Sarah who are harvesting them. This is a young plant. I did this a couple weeks ago, pulled it out of the ground because we're doing it in the fall as well. You see all these little bumpy growths here that look sort of growths? Those are all your nodules. This plant has only been in the soil about 3 or 4 weeks, and look how many nodules it's got that are all fixing nitrogen. So we've got 2 different plants doing 2 very different purposes. No, it's not the 500 different species of your, prairies, but it's definitely a lot better than just having one species in there or only having a couple of different crops on your farm. In addition to this year, these 2 wonderful farmers that have worked with us for several years really wanted to do flowers. There's a part of me that's very practical, and I want to grow stuff that you can eat and so forth, and they've really bowled me over with the importance of local chemical-free flowers, especially when we think about the flowers that most people are able to buy in the supermarket that come from South America often are covered in the worst chemicals. And the amount of diversity and life that it has brought into our farm is tremendous. And I hate to say it, but people pay more for pretty things than they pay for food. So it's also very much helping with our economic resiliency. So thank you, Katie and Nina. Isn't that pretty? Woohoo, yeah. More than crop diversity, perennials. Perennials are oh so important. Hedgerows, bed ends, fruit trees, even ground covers. Our hedgerows are super important for our farm. I'll talk about the animal side of it in a little bit, but climactic stabilization. You get this hedgerow here. This hedgerow is now about 8 to 10 feet tall, all Sonoma County native pollinator-friendly plants. It breaks the wind, but it also keeps the plants right next to it a lot warmer when we have a frost and a lot cooler when we have a heat wave. It just provides so much more stabilization, which is so important when we're having peaks of heat, cold, or whatnot. Our roadways, something that's really important to my husband is keeping green grass roadways. So we intentionally seed it with a lot of clovers. The bees love them. Over here you can see a hedgerow where we've started to put a lot of fruit trees. This is actually a brand new hedgerow because these fields were extremely exposed. So at this point we've got hedgerows throughout the farm, as well as our mostly green roadways that don't get irrigated, but even right now, the beginning of September, they are still green. This is a video a friend of ours took that sort of goes through the farm, and it starts at the top and works down. Those are my kids, by the way, and my dog Wengy, who was following the drone. You can see there's a native oak all along the top. We've got some animal paddocks here. We've got trees. Here's our first hedgerow that we put in on the day that we moved into the property, going all the way across the property here. Here we've got bed ends, another hedgerow that's got fruit trees. We've got fruit trees along the edge of the fields over here. Here's the new hedgerow I was putting in. One of our old ones, the one I was showing you with the California natives. There's another one coming down here with California natives. I've got more fruit trees coming along here. Got a bit of a forest. We've got what would be called the green wall, which is our barrier between us and our 140-acre monocrop neighbor. We've got a couple of seasonal ponds that have a lot of wild space that we've both planted and let happen around it. So that for us is extremely important in sort of, you can see this farm here. It just sort of holds it in place. It's not barren exposed, like drive down I-5, right? That's pretty barren exposed when you see that. And that's super important for us. Okay, moving on to the next principle of soil management. Keep the soil covered as often as possible. A, because you want green photosynthesizing plants in there, but B, you don't want to be volatilizing. And the soil biology, if it doesn't have cover, you know what? It gets really cold at night and really hot during the day. Nobody likes that. I don't like it, and the little bacteria doesn't like it either. So keeping it covered with green photosynthesizing plants, if at all possible, is our preference. If not, we will use artificial covers. This is a burlap for when we do direct seeded beds that require more open soil than I usually like. This is another organic mulch. This is straw that we'll use in the summer. Since we don't have any rain in the summer, it can get quite dry. So we'll do a lot of straw mulching of our beds, keeping that moisture in place, keeping the biology happy, and so forth. And they don't move that fast. That is speeded up. Okay, soil mulch. Exactly. They are pretty amazing. But sometimes then we also will use a plastic cover. And this we will use in the winter when it is too dark. We have too few hours to photosynthesize well enough to put in new baby plants. So we'll keep it covered. The biology likes it. It means that we can uncover the beginning of February, plant it like crazy, and we get very quick crops. We will also use it if we have too many weeds, so we don't have to open up the soil. We can decompose things in place. This is another video. This is March 2017, just showing you lots of different cover. You've got mulches. You've actually got some plastic there with some strawberries. You've got some plastic in the pathways, more mulch along the side of the bed. There's 3 beds that are completely covered. How many different varieties did we just see of different plants? Because this is March, there's not enough light to do too much intercropping, but there are definitely maybe 20 different varieties out there in that small field. The 5th and last principle of soil management is incorporating animals. Mother Nature didn't segregate her plants and her animals, and we should not either. Now, most people who talk about regenerative agriculture and animals are talking about livestock, and for a long time I was really sort of embarrassed when I talked about, yeah, we don't get our crops out and like move a herd of cattle through. And finally it hit me that no, I don't need to have a herd of cattle because there are a lot of animals that were already there. And our hedgerows actually help bring in a lot of this diversity. We have bobcats every year. We have river otters every year. We have bees. We have native pollinators like crazy. We have all sorts of beneficial insects. The hedgerows specifically really help bring in your beneficial insects. Beneficial insects are the predatory class. They have a longer lifespan than your pest insects. They need a little bit more protection. Just like your predator, the coyote, might have a longer lifespan and need more wild space and more protection than a little bunny rabbit who's going to reproduce quickly and have a very short lifespan. So having the hedgerows has increased our beneficial insects and also our beneficial animals. Our snakes love this, for instance, a lot of our birds and so forth. And that has meant for us that we don't have to use any sprays on our property because we've got a lot of biology doing the work and keeping things more in balance. Here's a snake eating a rodent. Rodents are actually our biggest pest on the farm. Gophers. Lady beetles, praying mantids, frogs. They don't call us Singing Frogs Farm for nothing. We've got a few of those. Birds, native bees. Most native bees are burrowing. What do you think happens when you till? You don't have them anymore. Little baby turtle crossing the road. Also incorporating animals. Another way we incorporate animals is through our compost. We bring in quite a bit of manure from off the property. We make about 50% of our own compost from the green mass that comes off of the beds, but we definitely bring in more because we are exporting nutrients off the farm every day. Yes, a lot come down through the work of the biology in the soil and photosynthesis and so forth, but we need more to come back from our community as well. So there we are. I know not all of you are farmers, but I think it's important, again, to understand these basic principles of how to keep the carbon in our soil, how to promote the carbon in the soil, both for capture and also for creating resilient spaces. This is a talk more on the why, not the how, but everybody really likes to see this. This is sort of the meat and potatoes of what we do, and I'm going to talk about it in terms of those principles. So this is a crop that we're transitioning over to the next crop, and what we're doing is we're clearing everything on the top level. We're taking it off. It's all going to the compost piles. You can see those full wheelbarrows. So we're transitioning from one crop to another. This is in March. Irrigation lines come off. A tiny bit of organic fertilizer goes on. Some compost goes on. It actually looks like a lot, but it's mostly the color differentiation. It's usually only about a 1/4 inch. We do have a tractor. It is our compost machine. Now we are transplanting not one, but 2 different crops. It's a lot of work, so you need your coffee break. So we've got a couple of different kinds of brassica here with several different kinds of lettuce that are going in between. That's the multi-crop that I was talking about. There's a green lettuce on the top row and then a red lettuce. Watering it in and they are done. Okay, so that is the how we do it in 45 seconds. And then as you're looking, this is a tiny little space. Many farms wouldn't want to deal with such a space. But when we're dealing on the human scale, when we're small, having lots of little spaces is lovely, and we can manage them all. We've got a hedgerow on this side. We've got a couple hedge plants over here. You've got some carrots there, and then more lettuces up there. We've got our sheep in the pasture right behind. So lots of life happening, lots of different things happening. The carbon and biology from these plants up here is helping these thrive, right? Without soil disturbance, with lots of love and hand labor. Okay. So to sort of wrap up how we do and what we do, no-till, not disturbing the soil at all, following those principles, being intensive, really staying on it. Because if you're not intense, a bed gets weedy and gets out of control and dries out. And then you're not helping the biology in the soil. So staying on it and producing crops, feeding our community, and making money is very much actually a part of keeping healthy soil for us. And then being ecological, really thinking about that biology. What are we doing to support it, to keep it as healthy as possible? That's what we do to produce healthy food. And then a couple of slides again. from earlier. I know I put these in the beginning, but just to remind you, it wasn't always that way, and a lot of farms that we see are like this. A lot of bare open soil. We're weeding on that day. We had a lot of weeds, a lot of soil disturbance. You can actually even see the gray color of the soil was very much like our tillage-based vineyard next door. It is the same soil. So that's where we started. And this is where we are now. A quote from Clara Nichols, and this came from a great class, an online class that's put on by MESA, which is a local nonprofit. They have a climate resilience and agroforestry class that I recommend. They ran it once last year. They will run it again. The goal of climate resilience is the ability of a farming system to absorb climate-related disturbances and adapt to stress and change while retaining its productive structure and yield. That's what we're talking about. So I showed you a couple of examples up front of some of the climate disturbances that we might have. I actually wanted to talk about them now since you have a little bit of idea of what we're doing. Drought, floods, and smoke are my example. We actually had a pretty dire situation about 3 weeks ago, and it was sort of a man-made drought. Our well pump went out for an entire week during a heat wave in August. That's huge for a farm, especially a vegetable farm, and especially during a heat wave. And for us, since we go year-round, in August, we are putting out all of our larger plants that will take us through February. So I calculated we had like $100,000 worth of produce out on the farm that was at peril because we had no access to water, our regular water, I should say. We had our farm crew just sort of continue on normal, and Paul and myself, jumped on the let's fix this problem as fast as possible. It took a week to order the part for our pump, which is why we were a week without water. So not a great picture, but weeks well in drilling out there. And what we found is we were able to get some surface water to, because we do have some ponds, we haven't used them in a long time, to, get us through that dire situation, but we were only able to have sort of a third of the water that we normally have. You know what? We lost one tiny little crop of baby bok choy, and we lost that because we made a mistake in our management. Our soil really held it together. By walking around the farm, you couldn't even tell that a lot of the crops hadn't had water in over a week. So having that healthy soil, super important when you have these disturbances. This is not climate change related, but it was a great example. Floods. I talked to you about how a large number of our fields go underwater every year. This is actually a challenge for us in terms of being intensive. I told you how important that is because these bottom fields, we can't plant anything in the winter for food safety reasons, right? You can't plant something and harvest it when floodwater came through here. See, I think I have a crop of. If it's young and you've got 90 days until harvest, it's okay, and that's what happened with this crop here. But one of the things we found when talking with other neighbor farms is when they have a flood or when they have a major rain and their soil is not able to hold that water and also hold the air in it. We had one time several years ago, our neighbor farmer called us in a panic. Help, how are you guys doing? We're dying over here. All our crops are just drowning in the soil. They can't breathe. And we're like, what are you talking about? Why? That rain we had 4 days ago. And we're like, yeah, we're totally fine. So with that higher soil organic matter and biology, the water comes, it goes, and things keep growing. So I'm worried about food safety, but in terms of the plants and the soil, I don't have to worry about it. The water comes, it goes, it moves around our irrigation and, some of our cloths, and is definitely a problem. But it helps us manage that for sure. The soil stays in place, the plants stay in place, and they continue growing and thriving. The next one, fires. Not necessarily a fire on our farm property. There's not much that the soil can mitigate with that, maybe the after effects. The campfire last winter was really harsh on us because of the amount of smoke. And the fires in Santa Rosa the year prior actually were very scary for us. They were 11 miles from our farm, was the closest that they got. And our community was devastated. And in the aftermath, just in days afterwards, people got freaked out. Is your food safe? Because ash was falling on everything. We had pages out of books falling down on us, right? And I was really quickly trying to do some research. I don't want to sell food that's not safe, that's got ash of who knows what on it, right? Is that ash going to contaminate our soil? Really interesting. As I was doing research, you know what I found? You have toxins in your soil. Increase your soil organic matter. Add compost. Inoculate with fungi. Increase your biology. I'm like, wait, that's all the stuff we do anyways. So we had the resilience to deal with that. We had studies come out after the fact, and they also showed that these were the things that were important. So with whatever comes at us, I'm hopeful that our best tool in our toolbox is the healthy soil. I'm not going to go over that. Life improves the capacity of the environment to sustain itself. I had already mentioned this a little bit. If you guys want to learn more, Mesa does a really good class. We are actually eventually going to do a class. If you guys really want to dig your hands in, any of you are farmers or no farmers, we actually do workshops on our farm. We have one this Friday and then one in next month. It's really fun to get a bunch of people out there and actually see what it is that we are doing. And these are our people. So these are the people that are working on the farm right now, making it happen, and I thank you all.